Okay, today we are going to be going over um, just domain and range. Um, Last time we dealt with domain and range, we were dealing with discrete functions where the domain and range were just your different x and y values. Here we're going to be going over domain and range of continuous functions, or in this case, continuous graphs. Okay, so first we need to remember what is the domain. All right, and your domain is just the set of all x values. Okay, so your domain is going to be the set of all x values that are in that function or in that relation. Okay, even the tiny little decimals that are in there, every single x value that is somewhere on that function. All right, the range is basically the same thing, but it's the set. Whoa, that's okay. The set of all y values. Okay, the set of all y values. So the uh, the domain was the set of all x values encompassed in that function. The range is going to be the set of all your y values encompassed in that function. So if you look right here at number 1, all right, and we're going to look at the domain first. So if you look at number 1, we've got a linear function right here. And we see that it stops right here, okay, and right here. So if we're looking at domain, we're really just looking at all the x values, okay? We're not worried about what the y values are yet. We're worried about the x values. So we can say, okay, well it stops at this x value right here, which is -4, and it goes up to this value right there, which is +4. Okay? So it goes from -4 all the way up to 4. And all the other little x values in between those are part of this function. So the way we would denote this is first we go ahead and put our values. It goes from 4 or -4 all the way up to 4. Now, -4 is the lowest value it can be. Okay? -4 is the lowest value it can be. But our x value can be higher than that. So we can say, well, -4 has to be less than or equal to x. Okay? And it's true. Our x value can be greater than or equal to -4. But our x has to be less than or equal to +4. And what we're really saying here is that our x is between -4 and 4 and can also be -4 and 4. So those values are included. All right. So now look at the range. Let's look at the lowest value we have, -3. Look at the highest value we have, which is +3. And we do the same exact thing. We can say, okay, it includes -3, but it can also be higher than -3. So -3 has to be less than or equal to y. And then it goes all the way up to 3 and includes 3. So y is less than or equal to 3. That would be the domain and range of the first one. All right, go over to number 2. Number 2 is another linear function, but there is another difference here. Notice on number 1, our endpoints right here and here were just closed dots. But if you look at them on number 2, right here and right here, they're actually open circles. And what that means is the values right at those points are not part of the function. So if we're looking at our x values, which it goes down to -3, and it goes up to +3. Negative 3 and positive 3 aren't actually part of the function, but all the values between them are. So we do it the same way we just did the domain in the other one. The only difference here is that instead of saying negative 3 is less than or equal to x, we would say negative 3 is just less than x. And x is less than 3. So x is between the two values, but cannot equal either of those values. Then we do the same thing with our range, with our y values. We go down here, it can equal negative 5, goes up to positive 3. Alright, so our range is going to be negative 3, or negative 5, sorry, is less than y, which is less than 3. Okay, let's look over here at number 3. Alright, we've got a couple endpoints here for our x values. Now, again, these are closed circles. So that means we're going to be using less than or equal to instead of just less than. So remember, closed circles on their ends, less than or equal to. Open circle on our ends, just less than. So, if we look at just the x values, because we're dealing with domain, we know it stops right here at negative 4 and goes up to here at negative 3. Or positive 3, I'm sorry. So it's from negative 4 to positive 3, including those two values. So our domain would be negative 4 is less than or equal to x, which is less than or equal to 3. Now let's look at our y values. If we look at the y values, it comes down to this point right here, which is negative 5. And it goes up here to positive 4. And we're going to say it includes the negative 5 as well. So we can say that negative 5 is less than or equal to y, which is less than or equal to 4. Okay? Alright, so what I want you to do is look at these last three right here and try to do those on your own, just the same exact way I just did the other ones. Just beware of limits. Like, for example, on this number 6, notice there's a limit right there. That's the high, and the low is right there. Okay, so that's what you're looking at. It's not always necessarily where your endpoints are as far as high and low. Endpoints typically go for the domain, but the range, you have to look at how high completely, totally, how high your function goes and how low it goes, not just at the endpoints. Alright, so give those last ones a try. Actually, wait before you do that. I'm sorry. I'm going to introduce one other concept here, so skip down to number 7. Now notice on number 7, we have a linear function again, but this time there are no endpoints. So we're not dealing with line segment, we have a line. Notice we get these arrows indicating that this thing goes on forever. Okay, now this thing, the line, is actually going to go on forever, both side to side and up and down. So there are a couple different ways we could do this. Alright? We could say that our domain goes from negative infinity. Alright? So our domain would be negative infinity is less than x, which is less than positive infinity. You can never use less than or equal to with infinity. Okay? It always has to be just less than. Alright? You could do the same thing with the y. You could say that negative infinity is less than y, which is less than positive infinity, or you could say that it is all real numbers. I was about to put an M there. Okay? They are both technically correct. Now, there's also a symbol for all real numbers that you will see sometimes, and it looks not the best at drawing it, but I'll try. It looks something kind of like that. Okay, so any of those will technically work. In fact, another way you'll see this written out sometimes is like this. Except actually it's not in a parenthesis. You use the curly braces, which I apologize, I'm not very good at drawing, but negative infinity up to positive infinity. That is another way to write the notation. Okay? All right. Now, let's take a look at number 8 real quick. Now, we've got our arrows again. All right? They're going down into the sides. Our arrows are going down into the sides, which means that our x values, it's going to go infinitely to the left and infinitely to the right. Okay? So we can say that our domain, since this thing is going to encompass all x values, we can say that our domain goes from negative infinity, is less than x, which is less than positive infinity. Okay? Now, here's the kicker. With the range goes down, keeps going down to negative infinity, but it doesn't go up to positive infinity. It stops right here. It turns right there. So, the way we would write this is, well, our maximum value is 4. Okay, our maximum value is 4. All our x's have to be less than or equal to 4. So 4 is greater than or equal to y. Or you could say y is less than or equal to 4. If it's opening up instead of down like this one is, it would be greater than or equal than the number. Okay, so what I want you to do is on your own, try 4, 5, 6, and 9. And if you need help, ask your teacher.